Hello everyone. Today in this video we are going to solve a problem by using a big M method. So if constraints are greater than equal to or equal to type, then following methods are applied: big M methods and two-phase methods. So in the big M methods, big M method is also called as penalty method. A very large penalty are assigned to artificial variable in objective function. For maximization type, minus m is taken as coefficient to artificial variables, and for the minimization type, plus m is taken as coefficient to artificial variables. So this modified objective function is solved by simplex method. So this is our question. So here question is solve the LPP using penalty method, that is a big M method. So the question is minimize z equal to 12x1 plus 20x2 subject to 6x1 plus 8x2 greater than equal to 100, and another one is 7x1 plus 12x2 greater than equal to 120, where x1 x2 greater than equal to 0. So we need to express this LPP into a standard form. So now we need to express the problem in the standard form. So minimize z equal to, and subject to, there are two constraints, so write down 6x1 plus 8x2. We need to subtract here one surplus variable s1, plus we need to add the very large artificial variable, that is a1, equal to 100. Here, because this is a inequation is a greater than equal to, this LHS is greater than equal to RHS, that's why we need to subtract something from this LHS to make this inequation into an equation. So 7x1 plus 12x2, again minus, again this inequation is greater than equal to 120. LHS is greater than equal to 120. So we need to subtract a surplus variable, and we have to add a very large penalty or artificial variable, that is a2, equal to 120. So minimize z equal to, write this one, 12x1 plus 20x2 plus 0 s1, write down the coefficient of s1 as a 0 s1, plus again in the second constant s2, so 0 s2 plus m a1, write the coefficient of a1 as a m, and for a2 same m, plus m a2. So as the problem is minimization, we have to take the coefficient of m as a coefficient of the artificial variable as a plus m. If question is in the maximization problem, then the coefficient of this artificial variable a1 and a2 coefficient should be in minus m, where x1 comma x2 comma s1 comma s2 a1 a2 greater than equal to 0. So here finding initial basic feasible solution. So write the here Cj, Bv, Cb. So basic variable, coefficient variable. So basic, we need to write in this row basic variables. So x1, x2, x1, x2, s1, s2, a1, a2, like a2. Just we need to write the variables x1, x2, s1, s2, a1, a2, x1, x2, s1, a1, a2 variables. Right here b, and another one is ratio, that is theta. And write down this basic variable column. In the column, artificial variables, that is a1 and a2 are the two artificial variables. So write a1 and a2. Now in the Cj row, we need to write the coefficients of this basic variables from the objective functions. So this is our objective function. So coefficient of x1 is 12 in the objective function, x2 20, s1 0, s2 0, a1 m, a2 m, a1 m, a2 m. So again in the CB row, write the coefficient of a1 and a2. So a1, a2 is m and m. So write the m. So now from the constraints, so a1 is in the first constraint. So in the a1, x1 value is x1 coefficient is 6, x2 coefficient is 8, s1 coefficient is 0, s1 coefficient is -1. As there is and there is no s2, it will taken as 0. And a1 is 1, a2 is 0, and b is the RHS here 100. Again for the a2 is in second constant. So coefficient of the x1 is 7, coefficient of x2, that is 12, coefficient of s1, there is no s1 in this second constant, so write down as a 0, and s2 -1, a1 just 0, a2 1, and here b is 120 RHS. Now this is zj, this is cj minus zj. So the formula of zj is 6 into m plus 7 into m. So that is a 13 m. For the x2 column, the zj is 8 into m plus 12 into m. That's a 20 m. For the s1 column, zj is -1 into m plus 0 into m. That is -m. We need to continue like that, -m. Again 1 into m plus 0 into m. So 0 into m, that is 0, 1 into m, that is the m. Here also m. After that zj for the b column, 100 into m plus 120 into m, that is 220 m. Now we need to write this cj minus zj row. So Cj is this row. Cj values are given here, and the Zj value is here. So Cj, that is 12 minus 13m, 12 minus 13m. So in the big M method, we need to consider in the Cj minus Zj row this 13m itself. We can't consider this 12, just 13m. And in this 20 minus 20m, 20 minus 20m, again 0 minus 0 minus minus m, that's m, 0 minus minus m, again m, 0 0, because m minus m, that is 0. So we need to select most negative value as a key column. So in the big M method, we can't consider this 20. We need to consider
minus 20m and minus 13m.
so the most negative value from this
Minus 20m and minus 13m.
most negative value 20m. So this is our key column. That is most negative column. After that, we need to find the ratio. So to find out the ratio, we need to divide the B column with the key column values. Suppose here 100 is there, so 100 is divided by 8. Again 120 divided by 12. So 120 divided by 12, that's a 10, and this is 25 by 2. So this row is the most minimum non-negative we need to select the most minimum non-negative row as a key row, and the key element is the intersection of key column and the key row is called as a key element. So this is our key element. So we need to go for the second basic feasible solution, because there is no Cj minus Zj row have the 0 and positive value, because this minimization the Cj minus Zj should be positive or 0. So we need to go to the finding second basic feasible solution. So again write down the here Cj, Bv, Cb. Here A2 is replaced by x2. This A2 is replaced by x2. So A1 here, x2. This key row is the outgoing row. So A2 is replaced by the x2. Key row is replaced by the key column x2. So again here x1, x2, s1, s2, a1.
So in the big M method, if artificial variable get as a key row, we need to neglect that artificial variable from the basic variable column.
So here b and theta. So write down the coefficient in the C0. So 12, 20, S1 is 0, S2 again 0, M, A1 M, and the x coefficient of x2 is 20. Now A1 and x2, here see just A1 and x2, just example this is. So this is just identity matrix, that is 1 0 0 1. So where is A1? So A1 is 1 0 in the A1 column. In the x2 column, this is the x2, so 0 1. If there is three basic variables in column, then suppose a1, a2, x2, just example this. So then you need to take 1 0 0 0 1 0 and 0 0 1. This is a identity matrix. To reduce the calculation time, just you need to uh, do this identity matrix. In the A1 column, just write 1 0 0, A2 column 0 1 0, and x2 0 0 1, as we did here, A1 and x2. So A1 1 0, x2 0 1. So A1, in the A1 column we wrote here 1 0, in the x2 column we wrote 0 1. Even if you calculate, you will get the same values. So here the key row in the previous, so this is a key row in the previous table. In the second table, we need to just divide the key row value with the key element. So suppose this is 7. So 7 is divided by 12. 12 divided by 12, that is 1. Just we told that identity matrix, that is 1 0 0 1. So x2 is 0 1. So 12 divided by 12, that's 1. And again 0 here, minus 1 divided by 12, 1 divided by 12, 120 divided by 12. Sorry, here okay, no, there is no a2. While solving a problem, be careful while removing this artificial variable a2. We don't need to write this. In the b column, we need to write 120 divided by 12, that is 10. So to find this a1 column, so the formula is, so a1, we need to find the value of x1 here. So in the previous table, that is in the first table, the value is at this block, that is 6. So 6 minus
corresponding row into corresponding column.
8 into 7 divided by key element, that is 12. The answer is 4 by 3. So write down here 4 by 3. So even if you do for this, you get the value as a 0. For the third block, a1 s1, so minus 1, just do here minus 1 minus
Corresponding key column, from the key column, corresponding key column minus corresponding key row value, that is 0, divided by the key element, that is 12.
So the answer is minus 1. Again for S2, 0 minus and 0 minus
corresponding,
key column value, that is 8 minus
corresponding,
key row, that is minus 1 divided by key element, that is 12. So we get the 2 by 3. Again for B value, 100 minus
corresponding key column into corresponding key row divided by key element.
100 minus 8 into 120 divided by 2L, that is equal to 20. So the value is 20. Here Zj, Cj minus Zj. Again the Zj value will be 4 by 3 into M plus 7 by 2L into 20. That is 4M by 3, 35 by 3. Again here 20, 0 into M, that is 0 plus 20 into 1, that is 20. Again here 20 into 0, that is 0 plus minus 1 into M, that is minus M. Here 2 by 3 into M plus minus 1 by 2L into 20. So minus 5 by 3 plus 2 by 3 M. So M in 20 into 0, that is 0 plus M into 1, that is M. So you can just 200 plus 20M. 200 into M, that is 20M plus 20 into 10, 200. Write the value of Cj minus Zj, 2L minus. So 1 by 3 minus 4M by 3, that is 20 minus 20, that is 0. M 0 minus this, so that is 5 by 3 minus 2M by 3, 0. So after completion of the second table, we can't get Cj minus Zj row as a 0 or a positive value. So we need to go to the third basic feasible solution, third table. So we need to select here a key column and the key row. So the most negative value will be here 4M. Here consider 4M and the minus 2M. Minus 2M minus 4M. So minus 4M is the most negative value. So this is a key column. So we need to find this ratio value. So B divided by the,
Corresponding key column elements.
so 20 divided by 4 by 3. So that is 15. 20 divided by 4 by 3, that is 15. Again here 10 divided by 7 by 12, that is 120 divided by 7. Most minimum non-negative value is this one. 15 is the most minimum non-negative value. As you do 120 by 7, that is 17.14. So most minimum non-negative value is this 15. So this is our key row. So this, now this A1 is the outgoing variable. So in the third table, this A1 column will be neglected, and this A1 value is replaced by key column, that is x1. So in the third column, again write down the Cj, Bv, Cb, x1, x2, s1, s2. This A1 is neglected, b and theta, and this A1 is replaced by x1. Just see, key row is replaced by the key column x1, x2. Write down the coefficient of this basic variables in the Cj row. So 12, 20, 0, 0. X1 is 12 coefficient, x2 20. Now in the previous table, that is in second table, the key row value will be divided by the key element. So key element in the second table is 4 by 3, and as you say that identity matrix, that is x1 and x2, there are two variables in the column, basic variable column. So 1, 0, 0, 1. So x1 1, 0, in the x2 column 0, 1. We need to find this this 4 okay, this 6 blocks. So s1, so in the previous table the value at this place is, in the s1, that is -1. -1 divided by 4 by 3, that is -3 by 4. And in the previous table at the place of s2, that is 2 by 3. 2 by 3 divided by 4 by 3, that is 1 by 2. 20 divided by 4 by 3, that is 15. And for the x2 row, we need to use the formula. In the previous table at the place of s1 there is a 0, so the 0 minus
corresponding key column into corresponding key row divided by key element.
key element is 4 by 3. So this is -1, so it will be 7 by 16. 7 by 16. Again for the s2 column, see the in the previous block, that is -1 by 12. So -1 by 12 minus,
Corresponding key column elements.
see the key column, this is a key column, and we are finding the s2, x2. So key column value is 7 by 12. 7 by 12 into
Corresponding
key row value, this is key row, so key row is value is 2 by 3 divided by key element, that is 4 by 3. This is a key element in the previous table, so the value is -3 by 8. -3 by 8. And for the b, so at the previous table that is value is 10, so 10 minus, so the 10 minus
corresponding
key row value, that is 20 into
corresponding
key column value, that is 7 by 12 divided by key element, that is key element is 4 by 3. So we got here 5 by 4. So now we need to find the Cj and Zj and Cj minus Zj. So as we know the formula of Zj, so 12 into 1 plus this 0, so 12, here 20 minus 1 by 4 minus 3 by 2, 205. So ZJ formula, as you know, this corresponding column into CB plus corresponding column into CB of second value. Here 15 into 12 plus 5 by 4 plus 20, that is 205. After that we need to find the Cj minus Zj. Cj value is 12 minus 12, that is 0, 0, 1 by 4, and this is 3 by 2. So as you see here, Cj minus Zj row have the 0 or positive value. So as all the element in the Cj minus Zj row, just here write down, as all the elements in Cj minus Zj row are zeros or positives, we need to write this optimal solution is x1. So x1 equal to 15, x2 equal to 5 by 4, and the minimum z equal to 205. So this is a minimum z, that is a 205. So we need to write this. So this is our optimal solution.